Hi everyone, we're going to start a lesson, but before we begin, I want you to pause the video and try the warm-up, which is from previous lesson that we did. I want you to find x if these two lines are parallel to each other. So this angle is 95, and I want you to find x if this is 2x minus 5. And then over here, we're going to have 105, 90, and 3x minus 18. I want you to see if you can find a x for this one also. So please pause the video and try as a review and then check with the answers. I'm going to show you the answers in a minute. Pause the video and try the warm-up. Here are the answers for the warm-up question. The first one, the x is 50, 95, and 2x minus 5, they are congruent because they are alternate interior angle. And if you look at the notes, alternate interior angle converse is what we use to prove parallel lines. So you can actually make it equal to each other. So 95 equals 2x minus 5. You're going to add 5, which is 100, divided by 2, which is 50. So x equals 50. This one, this line is trying to trick you. This is unnecessary additional information that you actually don't need. This angle, this line L and this line M, they are parallel to each other. So if this is 105, vertical angles are congruent. This is 105. If that's 105, then this right here will be 105. And 105 plus 3x minus 18, that is supplementary. Those are linear pairs. Any straight line is 180 degrees. So you're going to say 3x minus 18 plus 105 equals 180 because these two will be supplementary angles. So you're going to solve for x that way. Combine like terms, subtract, divide, you should get 31 degrees. This is consecutive interior angle converse because also right here, this one and this one, they're consecutive. If you look at this, they're inside and they're also consecutive interiors angles. So when consecutive interior angles are added, they're added to be 180 degrees, which is supplementary. So if you can also use the concept of consecutive interior angles converse to solve for x. So 105 plus 3x minus 18 is 180. So today we're going to learn about parallel and perpendicular lines. So the theorem is we're going to look at transitive property of parallel lines. If two lines are parallel to the same line, then they are all parallel to each other. If A is parallel to B, B is parallel to C, that means A is parallel to C. So it's a transitive property. So you're going to write A is parallel to B. This is a parallel sign. And B is parallel to C. Then A is parallel to C. So this is called transitive property of parallel lines. If two lines are parallel to the same line, then they are all parallel to each other. So line A, B, C, they're all parallel to each other. We're going to look at a theorem. In a plane, if two lines are perpendicular to same line, then they are parallel to each other. If line M and T, which is transversal, is perpendicular, and line N and T is also perpendicular, then line M and N is parallel to each other. So if two lines are perpendicular to the same line, so M and N is perpendicular to T, then they are parallel to each other. So this is a theorem for parallel lines. Perpendicular transversal theorem. In a plane, if a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. If line N and line L is perpendicular to each other, which means 90-degree angles, and line L and line M is parallel to each other, that means line N, the transversal, and line M is perpendicular to each other, which is 90-degree angles. So basically, if this N and this L is perpendicular, and this L and this M is parallel to each other, then N and M is perpendicular to each other. So in a plane, if line is perpendicular to one of two parallel lines, then it is also perpendicular to the other line. So this is called perpendicular transversal, this is a transversal theorem. Example. What is the relationship between segments AB and segment CD? Explain. Segment AB is right here. Segment CD is right here. They are parallel to each other because two lines are perpendicular to BC. BC is perpendicular to AB. BC is also perpendicular to CD. Then they are parallel to each other. As you can see, there are angles here, 68 and 22. They are add up. If you add 68 plus 22, that's 90 degrees. This one is 35 plus 55 is 90 degrees. By just looking at it, sometimes you don't know if it is 90 or not. If it has a little square, that means it's 90. If it does not have a square, then you gotta make a square, but you need the measurements. 68/22 equals 90. You need to prove that this is a perfect square 90. 35 and 55 is also 90, perfect square 90. So if AB is perpendicular to BC, CD is perpendicular to BC, then these two are parallel to each other. This example is referring to this theorem, where in a plane, two lines are perpendicular to the same line, then they are parallel to each other. So this is the theorem they're actually applying for this example. Another example, the map below is a section of a subway map. The yellow line is perpendicular to the brown line. The brown line is perpendicular to the blue line. And the blue line is perpendicular to the pink line. What conclusion can you make about the yellow line and the pink line? Explain. On the subway map, the yellow line and the pink line is right here, is perpendicular to each other, because the yellow and the blue are parallel to each other, and because they have a 90-degree angle here, so their corresponding angles converse checks out. So this line and this line is perpendicular to each other, parallel to each other, because their corresponding angles 90 and 90. Or the brown line here and the pink, their alternate interior angle, which is right here, is also congruent to each other. So that's also another way you can prove that the yellow and the pink is perpendicular, because this line, this angle, and this angle will be alternate interior angles converse. They are congruent to each other. Or you can use the perpendicular transversal theorem, which is right here. In a plane, if a line is perpendicular to one or two lines, then it is also perpendicular to the other. So you can actually apply this theorem to prove that the yellow and the pink is perpendicular. This is parallel, this is parallel. So you can actually use any of these reasoning and the theorem and proof to say that the yellow and the pink line is perpendicular to each other. So that is the video. So thank you for watching.